We're going to just talk about how you just crank through matrix mechanics. So not too much conceptualization here, but this stuff's important in terms of just getting familiar with the algebra of matrices. So there's two main operations in with matrices. The first is matrix vector multiplication. The second is matrix multiplication. So here we'll start with matrix vector multiplication. Here X is a vector and A and B are two matrices that are given by just these numbers. So here's an example. Let's do A times X. So here's A, here's X, and I'll color code these, so this will take me a little bit longer than usual. So the rule that you're going to follow is to get the first entry, you're going to go across the matrix row and go down the vector. So what I mean by that is you multiply each one of these guys and then add them together. So here you're going to take the top left corner and match it with the top here and multiply them together. Then once you're done with that, you add the 2. So I'm going across to the right and also down. So now I match 2 with the 3 because I'm going to the right and to the right in the matrix and down in the vector. So here this would be 2 times 3. And that'll give you a number. Similarly here, I do the same thing to get the second entry in the vector that it will output. I now go to the second row, and I do the same exact process. So do 3, and I match it with the 1. And then I take the 4 and match it with the 3. And then this will just be equal to 1 plus 6 and 3 plus 12, which is 7, 15. And that's your answer. So this is a x direction, x component has 7, and y direction has 15. Like I said, we won't conceptualize too much. So that's just the output. As far as matrix multiplication, let's do A times B. So A times B you can think of as essentially being the same thing as matrix vector multiplication. So to get the first, this will output a matrix. To get the first column of this matrix, what you do is you take A times the first column of the matrix, which I'll call B1. You put that as the first column. Then you take the second column, you figure out what that is, and then you put it in there, like this. So, and where this is the same operation as before. So how you do this is, so let's do this separately and then plug it in at the end. So this is the same thing that we just did. This is equal to go across, or I'll rewrite it. Let's do 3, 4. And then this is the first column. So that's 3, 2. This is the first column of B. I go across and down as before. This is equal to 1. Oh. So I match 1 to 3 and 2 to 2. So this is 1 times plus 2 times. And then I go down. 3 and 2. And then I do 3 times something plus 4 times something, though something is going down in order. just as before. And here, this is equal to 3 plus 4 is 7. 9 plus 8 is 17. So that's what you'll get. And then I'll leave as an exercise to do the second one for yourself. So you guys can pause the video and check if you get the same answer. If we do the second matrix vector multiplication, we get the following. We would get 1 times 1 plus 2 times 5 is 11. And then match the second row to do the same thing. So that's 3 times 1 plus 4 times 5, which is 23. So then to get the final matrix, you just take this result and plug it in. And that's about it for matrix vector multiplication. The only side note I'd say is notice that matrices are transformations. And notice that we output a matrix. So here, A times B, the best way to interpret this is that this is a new matrix that does the following. It takes a vector, it transports that vector to some other vector. Then it applies another transformation, A, to that new intermediate output. Is another way to think about it. So it's like you're doing two matrices on two different vectors is a way to think about it.